This lesson is going to show you how to deal with a system of three variables. And due to having three variables in the equations, we're going to be having three different equations. Otherwise, it wouldn't work out. Two equations for two variables, three equations for three variables. The way we're going to do this is elimination. So it's going to work a lot like the way we did it with two variables, except now we're going to see our equations with a z, just like these three. So our goal right now using elimination is to pair them up so that something eliminates. I'm looking at the green and the red, and I'm noticing one has a negative z and one has a positive z. I think that's a good way to start because if I add those, the z's are going to go away. So let's start by rewriting those two equations. And then the red one. And go ahead and start to eliminate. And so when I eliminate, I'm going to be adding this time because negative z and positive z added together is 0. And let's add the rest. 2 plus 3x is 5x, and y plus negative 2y is a negative y, and 5 plus 16 is 21. So that's 1. Now the second thing we're going to do is, I'm going to kind of box this guy because we're going to need him in a second. The second thing we're going to do is look at the other two. The other two, the blue one, it doesn't have the same kind of matching z. We're still going to have to use the blue and the green. So let's rewrite them. To x plus y minus z equals 5. And then our blue one for x plus 3y minus 5z equals 3. So if I try to add or subtract any of these, none of the z's are going to go away. Remember, we want to make z's go away because we made z's go away in the first elimination. If we messed it up and did x's, then the next step is not going to work. Now the only way to really get the z's to match is to multiply the top one by another 5. So what do I get? Our new green equation is 10x plus 5y minus 5z equals 25. And let's rewrite the blue one so that it's stacked ready for elimination. And now let's go ahead and eliminate. This time I have negative 5, negative 5. That means we're going to minus. So now the z's are gone. 10 minus 4 is 6x. 5 minus 3 is 2y. And it equals 22. So now we have two brand new equations. What we're going to do is we're going to take each of those and build what looks more familiar, a two-variable, two-equation system. 5x minus y is equal to 21. 6x plus 2y equals to 22. I see that neither the x's nor the y's are looking like they're going to eliminate, so let's match it up by timesing it by 2, so we have 2y and 2y. Here's the new equation. 10x minus 2y is equal to 42, and 6x plus 2y equals 22. Second equation is still normal. Now let's go to eliminate with addition. Y's go away. 16x is equal to 64, and divide by 16, and our x is equal to 4. There is one of the three parts of our answer. So what's left to do is now to plug this back in to one of these. Doesn't matter which one you choose, but choose one. I'm going to choose the first one. 5 times 4 minus y is equal to 21. 20 minus y is equal to 21. Negative y is equal to 1. So y is equal to negative 1. There we go. So now we have two parts. And the last thing is to use both the x and use the y in the original, one of the three originals. So let's try the very first one, the green one. 2, plug in 4 for x, plus y is negative 1, minus z equals 5. 8 minus 1 minus z equals 5. So 7 minus z equals 5. Negative z is going to be equal to negative 2. And so finally z is equal to positive 2. So z is 2, x is 4, y is negative 1. So my final answer is 4, comma, negative 1, comma, 2. An ordered triple. That's my final answer. Okay, let's look at another situation. Again, we're going to need to stack these so that something starts to disappear. Let's look through. I have 3, 5, and 1 on the x's, 1, 1, 1 on the y's, and 1, 2, and 1 on the z's. I think 1, 1, 1 on the y's is going to make things pretty easy. So let's start with that. Let's stack again the green one and the red one. Number 1, number 2 equations. 3x plus y plus z equals 1. Negative 5x minus y minus 2z equals 2. If you want to, set it up, ready to go on the other side, repeat it. 3x plus y plus z is equal to 1. And now the blue one, x minus y plus z is equal to 3. So these are the two that I'm going to set up for elimination. Elimination by adding will make the y's go away. 3 plus negative 5 is negative 2x. 1z plus negative 2z is negative z. And 1 plus 2 is 3. Over on the other side, elimination by adding makes the y's go away. 3 plus 1x equals 4x. 1z plus 1z equals 2z's. 1 plus 3 is 4. And remember, now we're going to take these two equations and put them back together into an old-fashioned system. Negative 2x minus z equals 3. And then 4x plus 2z equals 4. I have negative 2 and 4 on the x's. I have negative 1 and 2 on the z's. Neither of these are matching up, so let's go ahead and multiply the top one by 2 so that it will be a 2z for both z's. Alright, let's rewrite the system. Negative 4x minus 2z equals 6. There we go. Rewrite the bottom equation. Time to eliminate. Eliminate by adding will make the z's go away. Negative 4. Oh, look at that. X's also go away. So I have 0 equals 10. That is wrong. So again, remember, just like with the system of two equations with two variables, same thing in a system of 3 variables, 3 equations. If you end up with a 0 equals something else, then you know it's going to be no solution. But let's just pretend that I had done a problem and the problem had said equals 0, then that would have been infinitely many solutions. But this one doesn't. This one says equal 10, so it's no solutions. If you have any questions, please leave a comment, and I'll get back to you as soon as I can.